Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. I'm your host, Leon Jones. And in this segment, we're going to get simple and some science. And when I mean simple, I'm going to talk about simple machines. Now, as you know, in science, there are all types of equations, whether they're dynamics equations, statics equations, biological equations, any type of equation you can think of. There are different forces, different energies, kinetic energies, potential energies. But tonight, I'm going to present something real simple. So the title of this video is, what are the 6 types of simple machines? What are the 6 types of simple machines? Let me share my screen and we're going to talk about it. All right. When we deal with simple machines, as you see, there's quite a few of them. You have your inclines, you have your pulleys, your wedges. But when we deal with simple machines, what we're basically trying to do is move material from one distance or from one place to another place to a distance. And what are we doing? We're doing work. And work equals force times distance. Now, the reason why we use simple machines, it's because it makes it easier for material that you can't lift to be transported. So basically, when we talk about simple machines, we talk about doing work because work is performed by applying a force over a distance. Now, these simple machines, these 6 simple machines create a greater output force than the input force. So the ratio of these forces is the mechanical advantage of the machine. Now you see all 6 of the simple machines that you are going to see in this video have been used for thousands of years, and the physics behind several of them were quantified by the Greek philosopher Archimedes. Now, when combined, these machines can be used together to create an even greater mechanical advantage, as in the case of a bicycle. Now, the first simple machine that I'm going to talk about is a lever. Now, a lever is a simple machine that consists of a rigid object, often a bar of some kind and a fulcrum or pivot. Now, applying a force to one end of the rigid object causes it to pivot about the fulcrum, causing a magnification of the force at another point along the rigid object. These are levers. Again, when it comes to levers, there are 3 classes of levers, depending on where the input force, output force, and the fulcrum. When we talk about a lever, we're dealing with a fulcrum, we're dealing with a seesaw. Again, there are 3 classes of levers, depending on where the output force, the input force, and the fulcrum are in relation to each other. Now, the earliest lever was in use as a balance scale by 5000 BC. Now, Archimedes is credited with saying, "Give me a place to stand and I will move the earth." Baseball bats, seesaws, wheelbarrows, and crowbars are all types of levers. Now, my next simple machine that I'm going to briefly discuss is the wheel and axle. Now, a wheel is a circular device that is attached to a rigid bar in its center. Now, force applied to the wheel causes the axle to rotate, which can be used to magnify the force by For example, having a rope wind around the axle. Now, alternatively, a force can be applied to provide rotation on the axle, which translates into rotation of the wheel. Again, a force applied to provide rotation on the axle translates into rotation of the wheel. Now, it can be viewed as a type of lever that rotates around a center fulcrum. Now, the earliest wheel and axle combination known was a toy model of a four-wheeled cart made in Mesopotamia about 3500 BC. So what are examples of wheels and axles? Well, you have Ferris wheels, tires, and rolling pins are all examples of wheels and axles. Now, one of my favorites is the inclined plane. Now, an inclined plane is a plane surface at an angle to another surface. This results in doing the same amount of work by applying the force over a longer distance. Now, the most basic inclined plane is a ramp. Why? Because it requires less force to move up to a higher elevation than to climb to that height vertically. Now, no one invented the inclined plane since it occurs naturally in nature, but people use ramps to build large buildings, which an example is monumental architecture. And that happened as early as 10,000 to 8,500 BC. Now, Archimedes on plane equilibrium describes the centers of gravity for various geometrical plane figures. Then we get to the wedge. The wedge is often considered a double inclined plane. Why? Because both sides are inclined. That moves to exert a force along the lengths of the sides. The force is perpendicular to the inclined surfaces, so it pushes two objects. Example, you have portions of a single object. And what a wedge does, it basically pushes two objects apart. Now you have axes, knives, and chisels. They're all wedges. The common door wedge uses the force on the surfaces to provide friction rather than separate things, but it's still fundamentally a wedge. The wedge is the oldest simple machine made by our ancestors, Homo erectus, at least as long as 1.2 million years to make stone tools. Then we have the screw. A screw is a shaft that has an inclined groove along its surface. By rotating the screw or applying a torque, the force is applied perpendicular to the groove, thus translating a rotational force into a linear one. Now, it is frequently used to fasten objects together, as the hardware screw and the bolt does. Now, the Babylonians in Mesopotamia developed the screw in the 7th century BC to elevate water from a low-lying body to a higher one. Irrigate a garden from a river, that's the example. Now, this machine would later become known as the Archimedes screw. And then the sixth and final simple machine is the pulley. Now, a pulley is a wheel with a groove along its edge where a rope can be placed. It uses the principle of applying force over a longer distance and also the tension in the rope or cable to reduce the magnitude of the necessary force. Now, complex systems of pulleys can be used to greatly reduce the force that must be applied initially to move an object. Now, simple pulleys were used by the Babylonians in the 7th century BC. The first complex one with several wheels was invented by the Greeks around 400 BC. Now, Archimedes perfected the existing technology, making the first fully realized block and tackle. Now, overall, we must ask, what's a machine? The first use of the word machine or machina in Greek was by the ancient Greek poet Homer in the 8th century BC, who used it to refer to political manipulation. The Greek playwright Aeschylus is credited with using the word in reference to theatrical machines such as the Deus Machina, or God from a machine. The machine was a crane that brought actors playing gods on to a stage. Now, once again, when we deal with machines, we are utilizing them for work, and work is performed by applying force over distance. Again, there are 6 simple machines: the lever, wheel and axle, incline plane, wedge, screw, and of course, pulley. And that concludes this topic on the 6 simple machines. If you like what I just presented, please comment, share, and subscribe. Now, if you're looking for some hard-hitting political content, social issues content, check out the 411 Talk Zone radio show on YouTube and Blog Talk Radio. Now, with all of my channels, Blog Talk Radio, Mind the STEM channel, and the 411 Talk Zone radio show on YouTube. They're on YouTube and Blog Talk Radio. If you can't find me on those platforms, you can find me on Twitter for the 411 Talk Zone radio show on Blog Talk Radio, and YouTube. You can find me on just Twitter for the Mind of STEM. And I've put my STEM videos on the Mind of STEM because me, we, and Parler are political platforms. Also, you can donate. The Cash App is on my 411 Talk Zone radio show videos at the bottom of each video. But again, I want you to like, share, and subscribe to all the videos here on the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening. Thanks for viewing the content right here on the Mind of STEM channel.